All right, we are at chapter 14, fluid dynamics, um, or fluid mechanics, it's actually called. We're going to start off with section 14.1, pressure. So let's share the PowerPoint. And they start off with a plane, and you might think, well, yeah, the plane is a plane flies on the Bernoulli principle, which we will get to, the Bernoulli principle. But that's what, if you read the intro in the book, it's not really what it's talking about. It's talking about that uh, the runway in Denver is a whole lot longer than it is in Los Angeles, and that basically uh, runway length, let's say some runway lengths vary with altitude. Uh, Denver has a 16, I forget what it was, 16,000 feet runway, and LA has like 12,000 foot runway. And the reason Denver needs a longer runway is just because of the air density. So that's kind of the intro uh, to this section. Um, so let's talk about pressure. At any point on the surface of the object that's submerged in the fluid, the force exerted by the fluid is perpendicular to the surface of the object. So if we had a spherical, a ball, my wife has a ball right here. If we were to take a ball and submerge it, the pressure would be perpendicular to every point on the sphere. It would be like normal to the surface of the sphere. Um, so that's uh, so this object feels pressure on all sides, not just on the top, but even on the bottom. It feels the pressure on all sides. You can measure the pressure with a little device like this. The force exerted on the spring is uh, the we when we studied um, all the material properties, the Young's modulus, shear modulus, and bulk modulus, we're always applying pressure. Pressure was force uh, over area. The pressure is defined as the force over the area. Um, and so if you just look at a small portion of it, dF is equal to the pressure times dA, the small bit of area. So the force is equal to the integral of all the little forces is equal to the um, pressure times all those little areas. And the unit of force is the Pascal, uh, and it's equal to 1 Newton per meter squared. And atmospheric pressure is about 100,000. I forget the exact number, but it's over 100,000 pascals. But if you think, 1 Newton, you're used to being in the lab and you grab a 100 gram, zero point 0.1 kilogram mass. That's 1 Newton. You've held it in your hand before. You kind of understand what 1 Newton is. It's not 1 kilogram. 1 kilogram would be 9.8 newtons, or about 10 newtons. So 0.1 kilograms is equal to a newton. So you can imagine a newton on a square meter. You're familiar with working with your meter. So if you take a sheet that's 1 meter by 1 meter, 1 newton, that's not a lot of pressure. So atmospheric pressure is more than 100,000 um, newtons uh, per square meter. And that's uh, gives you an idea. Okay, now let's suppose you are standing directly behind someone who steps back and accidentally stomps on your foot with the heel of one shoe. Would you be better off if that person were a large male professional basketball player wearing sneakers, or a petite woman wearing spiked heel shoes? Well, let's do a little experiment. And I've got, as a matter of fact, so you can see it better. Um, I've got a little thumbtack here. I think you can see it, a thumbtack, and I'm going to put it between my thumb and my finger. And if I push, oh, that starts to hurt. That starts to hurt on the finger there, but it doesn't hurt on my thumb. I can turn it around, and now I'm pushing uh, down. Oh, and now it hurts on the thumb, but it doesn't hurt on the other side. So what is the point? Well, the woman in the spiked shoe is putting a whole lot of pressure um, on a small area. So the petite woman wearing spiked heels is all her, a lot of her mass, a lot of her weight is concentrated on that spiked heel. As a matter of fact, I think in some particular old museums that have wood floors, they don't allow spiked heels, uh, because it could ruin the floor. So the answer, let's get back here. You'd be better off with the large male professional basketball player wearing sneakers. You would feel less pressure. The woman in the spiked heel would uh, hurt more. And that does it for this section. Where next section 14.2 will be variation of pressure with depth.